In this video, we're going to go ahead and do examples of problems or factoring of trinomials whose lead coefficient is not 1. Okay, the same technique can be used for lead coefficients of 1. It's just going to be a whole lot simpler. So the very first thing we'd look at is step 1. Did we write it in descending order? And we did. Step 2, are there any greatest common factors of all the terms that we can factor out? In this case, we have 3 and 4 and 7. And nope, because 3 and 7 are both prime. They don't share any common factors other than 1. There aren't x's in all of them. And the lead coefficient is not negative. Remember, we don't like negative lead coefficients. So now, to do this, we are going to multiply the 3 and the 7 together to get 21. And then we're going to factor 21. 1 and 21, 3 and 7, until we get something that the two factors that subtract to make 4. Okay, and so 3 and 7 minus 3 is 4. Okay, so if we're working kind of right to left here. And so what we're going to do is going to rewrite negative 4 as 3 minus 7. The minus sign, this says that the 7 gets the minus sign. And so if I rewrite this, then I say 3x squared plus 3x, remember we're always keeping the x, minus 7x minus 7. And I gather those up, signs and all, and put a plus sign in between. Okay, so all we did is we rewrote that middle term. Now I factor through grouping. And so I can bring out a 3x here. That leaves me with x plus 1. Don't forget the plus 1. Most people will look at it and be like, oh, there's nothing left, so it's just 0. No, it's plus 1. 3x divided by 3x is 1. Okay? Plus, now I can pull out a negative 7. Always pulling out the negative, but I can pull out a 7 right along with it. And that'll give me x plus 1. In this case, I have common factors here, so that becomes one of my factors. If I gather up the other things, that's my other factor, 3x minus 7, and you're done. You can remultiply this out to check your work. Now, we could have guessed from here that my factors are going to have different signs. My larger factor, now here's the problem here. My larger factor is going to be negative. My larger factor is actually right here. That's my larger factor. Okay. And the other one, it didn't really matter because we didn't have things to multiply from out in front of the x. But here we do. And so the larger factor is whichever combination is biggest. And I usually use that more in the lines of setting up the grouping than checking my work here. But I could have guessed that my factors will have opposite signs, and they did. And because 3 is prime, then one has to, or the coefficient of one of the x's must be 3, the other one must be 1. That's it. Okay, so now there's just some tricks, and that kind of does the check. But you'd have to multiply this back out in order to check it. So 3x plus 1 is 3x minus 7x minus 7, and then when you combine like terms, you get minus 4x minus 7, and you're done. Okay, they all work like this, all of them. If it fails, it's done. It can't be factored. Okay, so our second example here. Now we do have a y that is in each plus a negative sign out front. So the very first thing we're going to do is factor out a negative y. It's already in descending order. And so factoring out a negative changes all the signs to positive. And so I get a positive 2. I had 3 y's. I took 1 away for 2 y's left. This is going to be positive 3. I had 2 y's. I took 1 away for 1 y left. And then I have a positive 1. And then I had 1 y and I took 1 away, and so there's no more y's. Now that's just removing the greatest common factor. Again, I kind of gather this term and throw it off to the side and concentrate only on this. I'll bring that in at the end. So now I'm going to multiply the two ends So I get 2, and I'm going to factor 2 instead of 1 and 2. They have to add to be 3, and they do. So now I'm going to take it, I'm going to split 3y up into 1y and 2y. Now I'm going to put the 2y with the 2y squared. You can put it anywhere, it won't matter. Plus 2y plus 1y plus 1. And now I'm going to gather everything up into my groupings here. Plus sign in the middle. So I can factor out a 2, and I can factor out a y from the first grouping there. So 2y comes out, and I'm left with y plus 1. I could factor out a 1. Always factor out, even if it's just a 1, and it becomes y plus 1 over here. That means that y plus 1 is one of my factors. The other factor is 2y plus 1. Now, bring the negative y down and stick it back in there. There's your answer. See, it's not that bad. I'm moving along on this mostly because in my previous video, in the more lecture-ish portion, I went and explained why things happen the way they happen. And so this is more along those lines of you have to do 500 of these and you'll catch on and you'll have it memorized. Okay, again, do I have any common factors? Well, there's no negative out front, so I don't need to factor that out. 20 is not divisible by 3, which means it doesn't share any common factors with 9 and 3. And there's not x's in all of them. Okay. Now, this is going to be one of those instances that I mentioned in the lecture part that you sometimes, man, when you do this, you get some huge numbers. Well, when we multiply 20 and 9, we're going to get 180. That's a big number. Now, there are some hints as to what you should choose. Okay, and this is, I mentioned one of my students developed a technique where she just factors the n numbers and she can pull them out from there. And again, if I can get a hold of this, man, I'll throw 3 or 4 examples up because that is awesome. Because this is a huge number for 180. I don't know the technique yet. But what I'm going to search for is I'm going to search for 2 numbers, because if you take a look at the central number, -3, that's a very small number when compared to 180, which means in order to find factors that subtract to give you 3, you're going to have to find factors that are very close together. I'm not even going to consider right now starting with the number 1 because it doesn't matter. It can't be that close. And so in that case, I'm going to start with 10. So 10 and 18. And 12, I think, goes into it. Well, does 4 go into 80? Yes. Does 3 go into 180? Yes. So 12 goes into 180. And so now if I divide 180 by 12, I get 15. And at that point, I can stop because 15 minus 12 minus 12 minus 12 is 3. And so that's how I'm going to break up this thing. The negative goes with the larger of the 2. Because that one is negative, then 15 takes the negative. And so I'm going to take 9x squared minus 15x minus 12x plus 12x minus 20. Remember, the signs are different. That's why the negative set here says I have different signs. And that's why I have my different signs here. All right, now if I factor this, then I gather this up, all the signs, put a plus sign in between. Now I factor out the greatest common factor from both sets of terms. So the greatest common factor of 9 and 15 is 3. The greatest common factor of x squared and x is x. And so I just divide. This is going to be 3x. This is going to be minus 5. Plus. The greatest common factor of 12 and 20 is 4. There are no x's in both, and so I don't have to worry about that. And so dividing 12 by 4, I get 3x. Dividing negative 20 by 4, I get a negative 5. And I have the same factors in both, and so that becomes one of my factors. Whoop. And the other factor are those two things. All right, that's it. Now we could make guesses if we look back at the original. We said that our factors must have different signs, and they do. And our lead coefficient, says that we either have to have 1 and 9 or 3 and 3. That's the only way that you can multiply to 9. And so we have 3 and 3, and so that works. Okay, the only true way to check is to multiply it back out. But this is the answer.